make sure that we have a pretty good understanding of how do we take some data, get regression results, interpret those regression results, and make some interesting statements with them, okay? So this time, I promise that I've cleaned up this data set, triple checked it. So it's probably too big. So let's blow this up a little bit so we can see it. So I think this was 2010 to 2019. I had every NFL play. Now it's difficult to work with play-by-play data, but I was just thinking, that might be interesting. We've talked about the hot hand a little bit, right? So am I make the previous shot? Am I any more likely to make the following one? Well, maybe the same thing could be going on with field goal kickers, right? I don't know if you've ever watched an NFL game and a play, kicker misses one or two. Oh, he's cold today. Oh, he's off, Well, as the last one still in his mind, So is there any kind of carryover from missing a field goal or making a field goal onto the next one? So it could be interesting. So I just kind of pulled out every single field goal. You can kind of see how the play-by-play data has all this goofy stuff in it, and you can use it, but we won't worry about that. What we're really kind of focused on is going over here. So for every player, we kind of have whether or not the field goal they kicked was made. We have the seconds that we're at in the game, right? So as we get kind of towards the end of the game, the seconds is going to get higher and higher. We've got the quarter that it was taken in, the yards that they would have had to go if they didn't kick it. We've got the distance of the field goal, the score differential at the time. I believe here, so it's the kicker's team. If it's positive, that means they were up by 3. If it was negative, it means they were down by, down by 7. Okay. And then we have whether or not they previously made their field goal. So pre-field goal made. I've got the number of field goal attempts that they took within this time period. And then I have what their field goal percentage is, right? So this is kind of trying to control for their overall quality. Of all the kicks they've taken in the NFL, what percent of them, and here I kind of did proportion, I guess I shouldn't have called this percent, but what proportion of them did they usually make, right? So kind of trying to control for quality there. So a couple things we could do. First of all, let's just run kind of our simple, maybe a naive regression. So we'll go to data analysis, scroll down here to regression. My Y variable is whether or not they made that field goal. Okay. So kind of some shortcut, Control Shift or Command Shift on a Mac, and I hit the down arrow, it'll select the entire column of data for me. So if you've got these larger data sets, that's really helpful as opposed to dragging with your mouse. So once again, that was Control Shift, hold Control Shift, or hold Command Shift, then hit the down arrow. We're then going to go to what control variables we want, or what variables we want on the right-hand side. Well, for now, let's just look at, did they make the previous field goal? Very naive, we're not controlling for anything. So Control Shift or hold Command Shift on a Mac, hit the down arrow. When you do this, you should have the same, have the same starting point and the same ending point in terms of your row reference. I selected the very first cell, which was the label, so I got to make sure that's selected. I'm going to put this on a new worksheet, so I hit OK. So I'm going to move this over. Just go call this naive, right? This is our naive regression. So here, it looks like if I make the previous field goal, I'm actually a little bit less likely to make the next one. Right? Now, the p-value is 0.67. So we haven't had this discussion a little bit, but if that p-value is 0.67, what does that mean? Yeah, I can't say that it's anything different from 0, right? So just a reminder of what we're doing there. So anytime we see a p-value less than what we'll call alpha, which is just kind of varying levels of confidence, right? So our alpha values of 0.1, 0.05, and 0.01. We said when we look at these stars, another way to think about this is really, can I reject a null hypothesis with 90%, 95%, or 99% confidence? Right? And when I say rejecting the null hypothesis is just what we assume to be true, which is that, and I shouldn't have put 0 here, just whatever coefficient we're looking at, I. We always assume it's equal to 0. So we always assume there's no relationship between our X and Y variable. If we find a low enough p-value, we can then start to reject that assumption. So here with 0.67, I mean, we're not even close to being less than even the 90% confidence alpha of 0.1. So here we can't say it's any different from 0. There's no effect from making the previous field goal. Okay. So that's kind of our naive regression. But we know that, well, maybe making field goals, if I'm looking at the same game, maybe game conditions can impact things, maybe the quality of the kicker, right? If I'm not very good and I missed the previous one, I'm probably less likely to make the next one too, right? And so we want to make sure we're controlling for some of these things. So we'll go back to our data, which I think I had here on, what was the other one? Oh, I did this earlier and I didn't mean to save it. I'm going to delete sheet 2. We'll recreate it here in just a second. So I've got my original data. I'm going to look at this and say, well, I could include how many seconds have went by in the game, the quarter that we're in, right? As I get towards the end of the game, maybe that impacts, right? There's additional pressure, the yards to go. So maybe, I don't know, if we're really close to a first down, maybe there's more pressure on me to make the kick, than if we weren't. We've got the distance of the kick, the score at the time. We can include all of these additional controls. Right? So that's what I'm going to do. So we'll go to the data analysis tab, regression, all the way at the bottom. Now my Y variable is the same, but I want to include every single X variable. So I'm going to select those labels, hold Control Shift or Command Shift on a Mac, hit the down arrow, then I can hit, I don't have to hit enter, I can hit this little button here as well. It'll send me back here. I selected the labels, I'll hit OK. Let's call this more controls, right? So it's not naive, right? We've added in more controls, things that we think matter. Now, we might not have everything that we think matters, right? It would be ideal if we had like weather conditions and other things. They're just taking more time to build a much larger data set. But I think we've got a lot of the relevant example or variables. So we'll look at this. We've got 5,000 observations, which is quite a bit. We'll go down to our coefficients and our p-values for all these different variables. Right? So if I was looking at this and I look here, which of these variables can I say has a significant impact on whether or not I make the current field goal? Well, the intercept, we don't really have to worry about if that's significant or not. That's just going to help us make predictions. So it's not that we're saying that there's a relationship with the intercept and making it, just that there's some base level, right? So, if you make it to the NFL, even if all the conditions are against you, you're going to be more likely to make a field goal than someone who's not, or who wouldn't be. And like there's some base like starting point. So we look at the other variables. Is anything less than 0.1? So 0.2 isn't. Yeah, so if we see these E's, right, that means move the decimal point this many places. And if it's negative, to the left. So 100. So this is a p-value of basically 0. I mean, 126 zeros and then a 4. This is very significant. And that makes sense. Kick distance is probably one of the best predictors of whether or not a kick is made. Right? As they get further away, they're less likely to make that kick. In fact, we can do a little bit better interpretation here. So if I'm going to try to interpret that kick distance coefficient, right, our general interpretation is one more unit of X predicts that Y would increase or decrease by whatever that coefficient amount is. So here, what would one more unit of kick distance be? So I believe if we go back and look at it, it's one more yard. So one more yard, well, I can say this better. For each additional yard further the field goal is taken, the expected or predicted decrease, because it's negative, in the probability the kick is made is what? Negative 0.011, or sorry, we already said decrease, right? So for every yard further, right, for each additional unit that the X variable goes up, the expected or predicted decrease or change here, if it was positive, it would be an increase. And the probability the kick is made is 0.011. So usually the effect is this is how many more units the Y variable would go up or down by. But when we have this 1, 0 variable as our dependent variable, the units are essentially probability, right? How much more likely am I to be in that one group relative to 0? And a lot of these sports examples, a lot of times our dependent variable is a 1 or a 0, right? So, you know, if we didn't have whether or not the kick was made, but maybe we had, I guess, the kick distance and, I don't know, attendance at the game or something, right? Then that would be an increase in the number of people attending the game, right? The number of units of that Y variable. But here, with the 1, 0, our units, you can think about it's just probability. So, you know, a probability of 0.01 is about 1%. So kickers are about 1% less likely to make a field goal for every additional yard that it's moved back further from the field goal post. Right? So that's kind of interesting. Now, what if I wanted to do I can type. What if I'm thinking about what would the effect be if a kicker were to move 10 yards back? Well, if I know the effect of 1 yard, the effect of 10 yards would just be, yeah, I just take the number of units. If I know the effect of 1 unit, to get the effect of 10 unit increase, right? Moving 1 yard, now I'm moving 10 yards back. Just take the number of units you want to move times whatever that coefficient is, right? Or because I did 10, you could just move the decimal point here. But I could even do, you know, well, maybe I'm not interested, maybe 5 yards back, right? And I could just get the effect of moving different amounts. And that's kind of interesting, you know, depending on the example, maybe the units are really small, right? So if I'm thinking about something like, I don't know, maybe I have like, how is attendance impacted by win percentage? Well, I mean, in the NFL, the effect of a 1% increase, right? That's your units, like win percentage. Well, you never actually see a 1% increase, right? Because if I win one more game, the percent increase is what? 1/16 times 100, whatever that works out to be. And so maybe I know that more realistic things would be, well, what happens if the win percentage changes by 20%? Well, if I know the effect of a 1% increase, the effect of a 20 would be just that coefficient times 20, right? The number of units that you're actually interested in the impact or the effect of. Does that make sense? Any questions on what I'm doing there? So we can kind of just scale these coefficients, right, to get different, you know, size effects. Looks like the only other thing that was significant here is the kind of career field goal percentage. Well, that makes sense, right? Like if I'm on average a higher field goal percentage kicker, it's more likely I'm going to make my current one, right? And I might have an issue with this variable that actually could probably solve here, but I don't know if I want to waste too much time. So we'll go up here. I kind of notice, you know, I mean, these field goal percentages are pretty high. I think I dropped kickers who had fewer than like 20 kicks in the NFL or something like that. So these are, you know, career kind of kickers. They all are pretty high percentages. So one thing I wanted to show you, and actually your question was great because I actually had already planned to do this, was to use this quarter variable. Well, what if like from the first, the second, and the third quarter, there's no really like additional pressure. There's still enough game to be played to where that might not impact the probability that they make the kick or not. But maybe in that fourth quarter, there starts to be a lot more pressure and maybe there's an impact there. Well, if I just include this quarter variable, it causes this to be linear. And in fact, it might be like 0 effect and then jut up a bunch once I get to that fourth quarter. So I want to be able to capture that. So I'm going to leave out the first quarter. That'll be my control group, right? But I'm going to include dummy or indicator variables for every other quarter. So here we'll do quarter 2, quarter 3, and quarter 4, right? We want to create indicator variables. So one way that you can do this in Excel is using an if statement, right? So these if statements check to see if something's true. If it is, it puts something in the cell. If it's not, it puts some, you know, another value. Well, we just want to create a 1, 0 variable. So we already know, like, we're either going to put a 1 if the statement's true and a 0 if not. So what do we want to check to see? Well, if this quarter variable is equal to, and here we want to know, is it equal to 1, right? Is it the first quarter? If it is, Oh, you're right. We're leaving out quarter 1. Thank you. Right? Yeah, this is the indicator for the second quarter. So we want to check to see if it's equal to 2. My bad. So if this is equal to 2, comma, put a 1. If it's not, comma, put a 0. And Excel kind of, well, before I close the parentheses, tells you like what it needs, right? Here's the test, comma, the value if it's true, comma, value if it's false. Okay. So we've got that. Now I want to do this for every observation. When I copy this down, what updates that cell reference to be looking at the quarter from that observation. Excuse me. So a good way to do this real quick is once I get to this black thick plus sign, if I double left click, it'll basically copy that all the way down to that very last observation in your data set. So that's a really nice shortcut, right? I don't want to drag that all the way down or type it out ever 5,000 times. So I can also do the same thing, but now is the quarter equal to 3, comma 1 if it is, comma 0 if it's not. And then if this quarter variable is equal to 4, comma 1, comma 0. And actually, so I've already got this filter on, so this would be a good one. What might I be forgetting if I only create these 3 indicators? Yeah, so if I go back here, I don't remember actually. So I can't remember if there is overtime in this data set or not. But if we had it filtered, sure enough, they coded it as a 5, right? So I could even just do overtime if that variable is equal to 5, comma 1 if it is, comma 0 if not. Right? So having it filtered was, made it a lot easier to check to see, oh yeah, is there overtime data in here or is there not? Okay. And then double left click. Now we've got all of our indicators. So now we don't really want to include this quarter variable. So all of our variables have to be right next to each other. Once I include these indicator or dummy variables, I don't want to include the original one, right? The whole point is that original one forced it to be linear. I'm getting rid of that, replacing it with these dummy variables. So I'm going to insert a column here just so I can move this out of the way. Because when we go to run our regression, all of our variables have to be in what Excel calls it contiguous columns, right? Where the columns have to be all next to each other. Okay? So that's why I had to move that variable over. So now, if I go to my data analysis and regression, now I could do, whether or not it was made as my dependent variable, and then my Y variable now goes all the way out here, Control Shift, hit the down arrow, got the same row, so that's good. Don't have any missing data or anything this time. So we'll go to View, we'll zoom in a little bit, and now I can kind of look at these results. Right? So what's kind of interesting here is, if I look at my p-values, okay, they're not significant, right? So it doesn't look like there's any additional impact from being, kicking a field goal in different quarters relative to the first. But maybe I just don't have enough data. And so maybe what do I do at this point? Right? Nothing's significant. Well, just because something isn't significant doesn't mean you don't want to mention the coefficient that you found. Right? So even though you didn't find strong enough evidence, you still found some evidence that said, oh yeah, you're actually more likely to make that field goal relative to the first quarter if it's in the third, fourth, or overtime is really close to it, but it's still positive, right? So you can still mention the size and the sign of the effect that you found. You just can't say that it's significantly different from 0, right? At the 90, 95, or 99% confidence levels.
This case, would you want to kind of lead out overtime since like it's so small and its p-value is so big?
Yeah, so I don't know if you necessarily want to leave it out. This time period, it would have been a good case to just drop all those observations because this was still, right, you only needed a field goal to win. I don't know what's going on here, if things changed over that time period. But just because it's small doesn't necessarily mean that you just want to leave it out, right? You still want to control for it, even if you don't find a significant effect necessarily. Is there anything else I want to say here? So we included some of these indicators up here. One thing that you could do, and it's probably, outside of anything that we will or what we have talked about. But when it comes to like your project, if you're looking at your data, well, maybe here, I think, maybe it's that kickers aren't more or less likely in that fourth quarter to make it, right? So I was thinking maybe there's some additional pressure. So like what's going on? But maybe it's that it really only exists for these kickers who aren't really, really high quality. So I'm going to sort this field goal percent variable. And then I'm just going to kind of look here through the data. It's got a pretty wide range. I'm going to just choose a somewhat arbitrary point and say, okay, if they have a kind of lifetime percentage less than 85%, so 0.85 here, right? So I'm going to go up here. Oh, no, I'm not. I'm going to try to sort, see if I can find it. Oh, so I'm going to go 0.85 right here. Okay. So every observation below this are for kickers who have higher lifetime averages, everyone below it lower, right? So what I'm going to do is I'm just going to select all this data and put it on a separate sheet, right? So I just use the shortcut to copy it. I'm then going to paste it. And then I'm going to go back. Well, I also need to know the variable names. So I'm going to go all the way up to the top here. Hold shift and just hit over, or I could do this with my mouse. And I'm going to paste those variable names in there as well. I would probably then want to do the exact same thing, right? But I'm going to want to go down to the same point. But now I'm only going to take the kickers who are less than 85% lifetime. So once again, using Control Shift to kind of navigate quickly, hit the over arrow, hit the up arrow. It'll only select these observations for low field goal. So this one was, we'll call them low quality kickers. And then this one was for high quality, right? Now I can run two separate regressions and it'll tell me, okay, what's the impact of kicking a field goal in the fourth quarter for low quality kickers? And then what's the impact for high quality, right? Maybe for high quality kickers, it doesn't exist, but maybe for low quality kickers, they're actually less likely to make it, right? So we could kind of explore this. So we go up to, actually, let's do it for the low quality and just see if we find anything. We may not. I didn't look at this. I was just kind of thinking about, I wanted to show you an example. Oh, sorry, I didn't mean to hit okay. So I went to my regression tool, right, under data analysis. I'm going to select this made variable, right, whether or not the kick was made. And then I'm going to go to my X variable and select everything else, right? So hopefully I've got the same number of rows. I've got my labels selected. Now when I'm looking at these regression results, scroll down here. Now it looks like the fourth quarter, so it's still incident. So there aren't any differences, but that would be one way I could find, like, if I have two different groups, high, low quality here, I could think about if I run two regressions, I could then compare, well, what's the impact for low quality kickers of being in the fourth quarter? What's the impact for the high quality kickers? In fact, let me see. So if we're actually thinking about that initial hot hand idea that we kind of looked at, for low quality kickers, it looks like they're less likely to make a kick if they made the previous one, and it's just barely not significant. So this is a good example where, okay, yeah, this isn't technically less than alpha, but I mean, is 89% confidence that much worse than 90, right? It's definitely still worth mentioning, especially since that p-value is so close to being less than that alpha of 0.1. If we're gonna go, where was the other one that we did? Was it, I'm gonna delete this, I accidentally created that. Here it was, so this was, we'll call this quarter dummies, right? But if we looked at kind of that effect when we use the entire sample, notice it was negative, but not statistically significant from zero, right? So it's negative 0.01, and then when we did that for low quality kickers, well, now the effect is negative 0.03, and it is significant. So really, when you ran everything together, you were kind of getting the average effect of making the previous field goal across low and high quality kickers. Well, if the coefficient you find on that variable for low quality kickers is a larger negative value, that means that you were getting the average. It means that for high quality kickers, it must be that the coefficient was a little bit higher, right? So we can kind of test to see if that's true. So we'll go to that high quality kicker one. We'll go back to our regression tool. When we have our made field goal variable, and then we have our, all of our controls. I select my labels, same number of rows, that's great. Now if I'm looking at this, sure enough, once I blow it up and you can actually see it, sure enough, for high quality kickers, so we'll call this high quality reg, and I'll post this after class so that you can kind of go back and look and see what we did. But notice now I actually get a positive coefficient for the high quality kickers from making their previous field goal. Not statistically anywhere close to being different from 0, right? A p-value of 0.8 is very high. So when I was running this all together, right, I was getting this result of, slight negative effect, not statistically different from 0. But when I separate it out by these two groups, I think might be impacted more, one impacted more than the other. Well, now for high quality kickers, there was no impact from making your previous field goal on whether or not you made the current one. But for low quality kickers, where is it? There you go. Who maybe we think might fall victim more to like this idea of overconfidence or something. Well, now if they make their previous field goal, they're actually less likely to make the next one. So, and it was very close to significant, right? I mean, might as well be 0.1067 is very close to being less than 0.1. So separating your data out into like groups and running like two separate regressions and then comparing the results can often like give you some pretty interesting insights into whatever the question is. Okay. All right, any questions or anything that we did in Excel here? I wanted to make sure that I got kind of worked through a pretty good example and show you a couple of little things, creating indicators, separating the data up. Now, I know I mentioned this before, but like good practice is always to do like this copy and paste thing because you want to make sure you don't delete any of the original data. Also, I don't know if it was this class, I do some of my stats class as well, but if where was one that I had filtered? I don't think I had any of them, so I'll filter this. So one issue with, let's say I go to my original data and, hold on, I already have it filtered. So I go to here, and maybe I just start deselecting everything below 0.85 so that I only have that sample. But when I do that, it'll look like, okay, now I can run a regression. Like I can use a filter tool and then run my separate regressions. The problem is, notice, let's see, we need an example where it makes a jump. Oh, never mind, it'll only be the very first one. So notice it jumps from like 1 to 223. Those other 221 observations are still like in there, you just can't see them. So when you select that column, it'll select a bunch of the data that you aren't seeing. Right? It's not actually like deleting the data or only using the data that you see. It's still kind of floating around in the background, right? So you can't just simply run two separate regressions in Excel using the same data set, which is why I kind of copy and pasted it into two separate sheets there. Okay. Questions on this? So we got this paper, but I pulled a lot of stuff out for it and put it in slides to make it a little bit easier. And then we'll look at the PDF of the other one. So from 1992 to 2002, 7 of the 92 head coaching positions, right, were minority candidates, right? So I believe this is thinking about head coaching jobs as head coach, but like, right, there's movement in and out, right? So it's not there's just 30 head coaches, it's over this entire time span. A lot of coaches work for several years, some of them don't. So we had 92 different vacancies, right? Ability to hire coaches. Only 7 of those times was there a minority candidate hired. So the NFL saw this, they're like, this is a problem, right? And so they instituted this thing called the Rooney Rule, which I forget all the exact details, but the idea is that you have to at least interview a minority candidate when you have this head coach position open, right? Or you have a coaching position open. So after that, we saw the kind of number rise from 7 to about 17. And it was out of about the same number, right? Not quite as many vacancies as, but about the same. So a much higher percentage of minority coaches were being hired in these interview processes, right? So we've got the racial composition. So what? 72% white and 27% black if we look at all coaching positions, right? So it's already skewed a little bit. And, you know, we could say, is this a good or a bad thing? Well, it doesn't line up with the kind of percent breakdown we see of the players in the NFL, right? But it's a little bit higher than just overall the population in the US, right? So, you know, we could go either way on that. So this paper wanted to look at, you know, whether or not we can control for all these other factors. Does it look like being, you know, black as opposed to white decreases my chances of getting this head coaching position or any coaching position? So one thing we can think about, we could see some discrimination going on is what we call allocative discrimination, right? So it could be that initially, right, it's more likely that we're hiring coaches into lower wage positions or positions that have lower starting wages, right? And that means less likely that they're starting out in the positions that have higher wages, right? So this would be the idea that when they initially get hired, they're less likely to get hired as a college coach at University of Alabama, right? And more likely to be hired as a coach at, I don't know, pick your seal. What are some of the schools, Alabama A&M, or, you know, one of the smaller kind of schools in the state. Right? So maybe it's that their initial job, even in college, or their initial kind of position starting in the NFL is lower. So maybe it's more likely that a white candidate gets a job as a quarterbacks coach as opposed to a black candidate. And maybe it's more likely the black candidate is getting, you know, I don't know, you know, DB coach or wide receiver coach, which if we look at the path to becoming a head coach, usually it's a little bit more likely if I start out as a quarterback coach as opposed to these other position coaches, right? So maybe I've got some things where discrimination isn't going on in the process of determining who is the head coach, but the reason why black candidates are less likely to be hired as a head coach is because they were less likely to be even hired as a coordinator, or even less likely to be hired at these positions that are more likely to become head coaches, right? So the discrimination was like way back in the future, or in the future, way back in the past, right? So within job, this would just mean how we typically think of discrimination, right? I've got two coaches, they're both offensive coordinators, you know, but the black coach is less likely to be hired as a head coach. That's kind of the traditional within job, right? But the allocative one could be what's happening as well. Okay. So if we think about the hierarchy in the NFL, generally you've got a head coach, you have two coordinators, and they kind of have position coaches underneath them, right? And each one of these different position coaches has a different probability of being hired as a coordinator, right? So for instance, if I'm looking at my defensive coordinator, and I don't know if this is true off the top of my head, but I'm using this as an example. If I'm a special teams coach, right, it's more likely that a special team coach becomes a defensive coordinator and less likely that a linebacker coach becomes a defensive coordinator. But it's more likely that we have black coaches being hired as linebacker coaches and more likely we have white coaches being hired as special teams. Well, then we have allocative discrimination going on, right? Because now the path to getting the head coach is going to be easier for that special teams coach as opposed to the linebacker, right? So that will be kind of the idea. If we look at the breakdown, we see very different percentages in terms of race at each one of these different coaching positions. So this was, I forget what year of the data they were looking at the time. Kind of if we think about our first coaching job, so this isn't what their current job, but what was their first job in the NFL? Notice there wasn't a single black coach in the sample where their first position was an offensive, defensive coordinator or a head coach. Right? Not, you know, who would these coaches be? Probably college coaches that were getting hired as their first job. And you then kind of look at the breakdown of these other first positions. Well, look at the quarterback coach. I mean, almost exclusively white, not quite, right? And then you've got other positional coaches that are, you know, have a higher percentage of black than white coaches, but there's definitely variation across each one of these different position coaches. So if some position coaches have easier paths to becoming coordinators, we're going to see some what we call kind of allocated discrimination. And don't worry about this. I think this is maybe a little more complicated than what I wanted to go through. But basically this is all this was getting at, is that these bars represent a defensive coordinator has the highest probability of being hired as a head coach, offensive coordinator next highest, DB coach, offensive line, quarterbacks coach, et cetera, et cetera. And then the paper also kind of thinks about, well, maybe there's something going on with, you know, a lot of our coaches in the NFL were also players. And so maybe it's not just their race, but like what position they played in college. Right? So maybe, maybe we think about that they're given different opportunities based off of what position they played. And we look at the positions that are played in NFL, you know, the percentage, the racial percentage or the percent that are white or percent that are black at each position also varies, right? So maybe it's not through like actual like evil intent discrimination. Maybe it's just coming out of the fact that different players who play different positions are given different opportunities, right? So they run this regression and we'll kind of give you what the equation would look like. So we'll think about this. So here we've just got basically, were they hired 1 or 0 is our dependent variable. We then have our intercept. We have the slope coefficient or the slope estimate on whether or not that coach was black. So this is just a 1, 0 variable. So this is the primary variable of interest. A 1 unit increase in my X variable would be if a coach was black relative to white, what's the change, or what's the change in the predicted value of whether or not they're hired? Well, if I have a 1, 0 variable, we said the predicted change really represents increases or decreases in the probability of belonging to the 1 group versus the 0 group. So here, a black coach relative to a white coach for the group that's a 1 relative to 0, the expected increase or decrease in whether or not they're hired would be whatever that beta 1 is, right? Whether that slope coefficient is. And then, you know, we add in a bunch of controls. So, you know, there's a bunch of, we try to get performance measures of that coach in terms of how their you know, current team or in their current position, how that they're performing. You know, maybe we do age, we do a whole bunch of different controls there, right? So that's the kind of regression equation we're looking at. So now here they've bolded, right, this variable they want you to pay attention to. They have different performance measures. And I forget exactly what they all are. If you kind of go through the paper to be a little more detailed, their coach's age, experience, whether or not they were a coordinator or not, because we know that coordinators are more likely to be hired. So we're controlling for this now. Essentially, if we include all these additional controls, we can control for that allocative discrimination. And really, this should be reflective just of within job discrimination. They did things here where they change the dependent variable. So usually it's head coach. So were they hired as the head coach or not? And then they have this one, which is any position. Right? And then they also limit the candidates. So they say, okay, I'm looking at defensive and offensive coordinators. Are they more likely to be hired to a head coach if they're black, right? And then they, what did they do here? Oh, so they had different time periods as well, right? They have all years before the Rooney Rule, years after. So here, if I only look at the defensive and offensive coordinators who are in the NFL, and then look at what was their probability of being hired as a head coach, if they were, oh, no, actually, I messed this up. I flipped it. It doesn't really matter. All right, instead of black being 1 or 0, they kind of had it identified as a white. So here, instead of what's the decrease in the probability that you are hired because you're a black coaching candidate, it's going to be the increase in the probability because you're a white candidate, right? Those are really just two different ways of saying the same thing. So we've got only our coordinators, offensive and defensive. The probability that we see a white coach hired, with the increase in the probability that, that we see them hired as a head coach, we get estimates of about 0.5 and negative 0.1 here. So after the Rooney Rule, it looks like maybe they're a little bit less likely to be hired as a head coach if they're white. But really, our standard errors are so large, we don't have any significance. So if you were a coordinator, it doesn't matter if it was pre-Rooney Rule or after the Rooney Rule, it was no more or less likely that you were hired as a head coach because you were white. But that was only limiting it to defensive and offensive coordinators. quite often, sometimes people will jump that step, right? So here, if I'm just looking at any position, right? Or sorry, actually, let's go over here first. If I'm looking at all these other different coaching positions, so not just offensive and defensive coordinator, but the tight ends coach, the special teams coach, now the probability they get hired as a head coach, if they're white, increases by about 0.74. So this huge increase in the probability that you see kind of coaches who aren't coordinators jump up to head coach, right? So this is some evidence that maybe there was some discrimination going on, not within job, right? Not where most often we see, right, offensive, defensive coordinator to head coach, but from all these other positions, right? Well, the problem is we know these other positions, it's more likely that you hold one if you're white or black, depending on what position we're looking at least if we just look at the breakdown, right? If we went back to this guy here. So if it happens to be that more cornerback coaches are able to be hired as a head coach, well, there we would actually see that's like more likely that black coaches are hired to this head coach position, right? So maybe we want to control for what their current position is. So we'll go down here. Excuse me. So they start to add in some additional controls. You can see some of them here, but really the one I want to focus on is when they have everything in here, right? So they've got first position fixed effects. So all that means is they included an indicator variable for what that coach's first coaching position was. And they also kind of included what their current coaching position was. So it should be now, we've got two offensive coordinators. They both started out as quarterback coaches. Same experience playing in the NFL, same coaching experience at both levels. They tried throwing every control you can think of. So you've got two otherwise identical coaches. One of them's black, one of them's not. What's the additional increase in the probability, or I shouldn't say black, one of them's white, one of them's non-white, right? What's the additional increase in the probability that white coach is hired, right? So if I'm looking at kind of this column here, that was where we included all of these additional controls, right? And now it looks like the probability of being hired as a head coach, not statistically different from zero, right? Looks like there's no additional change in the probability that you're hired as a head coach if you're white relative to non-white. Holding constant, right? All those other things, which is a lot of things, right? So looks like awesome, great. We solved it once we control for everything, no discrimination going on. Problem is, if we then change our dependent variable, so I said earlier it was hired. Up to this point, we've been thinking about it hired as a head coach. Now let's change that. Actually, not offensive, it was just simply, was I hired as an offensive or defensive coordinator? And if I know that offensive and defensive coordinators are more likely to be hired as head coaches, then it would make sense. If I see discrimination going on at this level, it would impact how many black head coaches that I see when I'm just looking at the numbers. So now, if I looked at the dependent variable being, am I hired as a coordinator, holding constant all these other things still, well, now that's where the strong effect was really coming from, right? So now if I'm white, the probability I'm hired as a coordinator, relative to a black coach, holding constant, all these other things, it increases by about 0.76, right? So the real discrimination is going on well before you get to that head coaching interview, right? So